Howdy, MEEN 611 students. This video is specifically for you for your MEEN 611 Lab Number 4 handout. Before I get too far into this though, let me just mention that even though your Lab Number 4 is different than MEEN 410 students, there is a substantial amount of overlap between their Lab 4 and your Lab 4. So the redundant items that are the same between the two labs, the two classes, I'm not going to repeat in this video. So you're going to want to watch MEEN 410 Lab Number 4 video in addition to this video. I'll only be describing the specific elements that are unique to MEEN 611 Lab Number 4 in this video. Okay, so, and of course, if you happen to be a MEEN 410 student, you're in the wrong video. You'll want to make sure that you get the right handout, the MEEN 410 handout. This handout is only for MEEN 611 students, okay? Okay, so as I mentioned just now, things like the objective of this lab, as well as the main independent parameters that you'll be studying, are all described in the Lab 4 video, and so I won't repeat that here. So again, MEEN 611 students, you're going to want to watch the MEEN 410 Lab Number 4 video, okay? Likewise, in creating the various plots, I describe the details about the in-cylinder pressure data, so I won't repeat that here. But I will go into detail about item number 2, which is the first unique feature for MEEN 611 Lab Number 4. MEEN 611 students will be calculating the rate of heat release as a function of crank angle for each spark timing for the two engine speeds that we're studying in this laboratory, okay? What I would encourage you to do is to use this equation that's given in your MEEN 611 handout. This is a simplified version of rate of heat release that's provided in Dr. Haywood's Internal Combustion Engine Fundamentals book, okay? I provide the pages, I provide scans of the pages from that textbook on Canvas that go through and give a fairly high-level description of how this equation is derived, okay? I'm going to skip ahead very quickly and just mention that one of the things that you need to describe in your Lab Number 4 write-up is the derivation of that simplified rate of heat release analysis equation, okay? So to help you with that, you need to make sure that you read the paper that's given to you on Canvas, this paper that's titled Instructional Use of a Single Zone Premixed Charge Spark Ignition Engine Heat Release Simulation. If you read that paper, along with the select text that's given to you from Dr. Haywood's book, you'll be fine in being able to do that derivation of this equation, as well as provide the analysis of the assumptions that go into deriving this simplified form of the equation, okay? Okay, and then item number 3 is that you will also be calculating mass fraction burn as a function of crank angle for each spark timing, plotted for the two different engine speeds, okay? And so you can calculate the mass fraction burn using this equation here, which is basically the integration of the heat release from the spark timing up to some crank angle divided by the total integrated heat release from spark timing to end of combustion, okay? And so this is basically, if I just very quickly draw for you what this plot will look like, if this is the burn fraction as a function of theta, top dead center, for example, might be right here, your mass fraction burn curves are going to look something like the following, okay? And so you will be able to calculate this curve that we have here using this equation that we have here, okay? Okay, items number 4 and 5 are described in the MEEN 410 video, but an additional note specifically for MEEN 611 students is that I want you to determine your own 10% mass fraction burn data from your calculated data, okay? So the data that's given to you in the Lab 4 data spreadsheet is calculated from my mass fraction burn calculated data. I want you to determine your own 10% mass fraction burned location from your calculated data, okay? And one of the items that you'll be describing in your analysis is the similarities or differences between your combustion locations and those that are given in the spreadsheet, okay? So you'll be calculating 10% mass fraction burned, 50% mass fraction burned, and 90% mass fraction burned. And I want you to analyze your calculated burn locations compared to those given in the spreadsheet. They should be very, very similar, right? Within, I'd say, anywhere from half a degree to at most a degree in terms of similarity. And so if you're different from that, if you're, say, more than 1.5 degrees from what's provided in the spreadsheet, then there might be a mistake somewhere in the calculation, okay? And so you want to make sure that you think about that and analyze that, okay? And then item number 6, plot number 6, is the same as that which is described in the MEEN 410 Lab 4 video. Okay, so now when you after you have your plots created and you start writing up your Lab 4 report, the various analysis that I'd like you to do is provided for you in these various bullet points that you see here. And again, much of this is already described in the MEEN 410 Lab 4 video, so I won't repeat myself here. The one item that I'll highlight is because you do have more analysis that you need to do than the MEEN 410 students, I think realistically a well-written lab report might be somewhere between 10 to 15 pages. Okay, you've got more data to show, you have more analysis to do, and so I would expect your lab report to go a little bit longer than the MEEN 410 students, okay? So the first item that we've already discussed, so I won't repeat it to a great extent here, is doing that analysis, the derivation and the analysis of the simplified rate of heat release equation that's provided for you above. That'll be the first thing that you want to describe. You then want to go into great detail about analyzing the rate of heat release curves as well as the mass fraction burn curves as functions of crank angle, as both engine speed as well as spark timing change. And just like I did in the MEEN 410 Lab 4 video, I provide some various items for you to think about to formulate complete discussion. So for example, questions that you can ask yourself include, do rate of heat release and mass fraction burned vary as expected with spark timing? Why or why not? Does engine speed affect rate of heat release in any way? Does it affect mass fraction burned in any way? And again, explain why or why not. This bullet point here, where it describes behavior of brake torque, indicated torque, and IMEP with spark timing for each speed, is described in the MEEN 410 Lab 4 video, so I won't repeat that here. Likewise, we already described this bullet point in terms of explaining the similarities or differences between your calculated combustion locations, 10% mass fraction burned, 50% mass fraction burned, and 90% mass fraction burned, and those that are given in the spreadsheet. So you want to make sure that you explain whether your values match those values given in the spreadsheet and any differences or discrepancies that might exist between the two. The next bullet point, asking you to explain ignition delay and combustion duration with respect to each other and to spark timing, is already given to you, or is already explained in the MEEN 410 Lab 4 video, so I refer you to that MEEN 410 Lab 4 video to learn details about this bullet point. And then finally, the last bullet point describing brake fuel conversion efficiency is also described to you in the MEEN 410 Lab 4 video, okay? So with that, that is essentially everything that's expected of you in Lab 4. Again, the major emphasis that you'll be focusing on compared to the MEEN 410 students is that rate of heat release analysis. That's an extremely powerful tool, and as you'll learn, of course, both in class as well as in reading these articles, it's all based on doing a first law analysis, a thermodynamic analysis of your control system during the combustion process, and it's pretty cool stuff. Okay, enjoy lab number 4. If you have any questions, please feel welcome to reach out to either Kyle or myself. Thank you and have a great day.